Hello everyone. Today we start chapter number 10 and we discuss vector, integral calculus and integral theorems. So the first topic that we discuss today is line integral. Now the concept of line integral is a simple and natural generalization of a definition of integral that we normally calculate is from. For example, if you want to calculate an integral, you have a limit that start from a to b, f of x, d of x. So normally these values a to b is on a line segment, so we didn't bother what type of line we are following. So but this is actually a definition of a line integral. Now because this line is a simple one, and that I told you that this is just a line segment, so it doesn't make much difference. But sometimes you don't have a single simple line segment, you do have some curve. So in that case you have to use the same formulation, but you have to do a little change so that you can traverse whole the curve. Now in that case how we do that actually? Now we want this integrand, that is f of x here in equation 1, uh, to be evaluated along a curve that is in a space or in a plane. So how we do that? Normally the first thing that we need to do is that, because curve can be of any type, so what we want to do, we want to make it simple. So how we do that? We just parameterize that curve so that it can be represented by a straight line, as we have here in equation number 1, where we have a line segment. So this is the basic thrust of line integrals. Now how we do that? So in that case we can use a vector that is parameterized with respect to time t, and we have three components, that is x component, y component, z component, that is also a parameter of t. Now if I can write in terms of unit vector, I can say that this vector that is parameterized is between t is between a and b, and these are x, y and z. Now these are some examples that we do have different types of curves here. Look here, there's a one curve that is a simple one, and which start from A and ended at B, but curves is going from A to B. So this is one type of curve. There's another type that is known as closed curve, where A, B coincide each other, and we start from A and end at B. Now the arrowhead is shown on these curves. So the main idea here is arrowhead is because we just want to show the direction, that as we increase the t, how you move from point A to B. So if you move from point A to B, so this means that t is in increasing, or t is in positive direction. Or if we want to move from B to A, then it is in negative direction. So arrowhead is represented towards the positive direction. Now then we call another formulation, that we call it as smooth curve. Smooth curve is one which has direction varies continuously as we move along it. Okay, so general assumption is that we normally here consider a smooth curve, or in other words a curve which has differentiable on all the points. Now definition of in line integral on a curve can be written as c this is a subscript C and f of r dot dr. Okay, similarly, or in other words, if we use the parameterized r of t, then it becomes a to b f r of t dot r dash of t. So this is actually the line integral. So in other words, if you want to just further clarify it in terms of component, it can be equal to a to b f1 x1 dash plus f2 y1 dash plus f3y f3z dash times dt. Now if you have a closed curve, then we just draw a close or circle along the integral so that it shows that we have a closed curve. So this is an example which we do and we stop after that. An example is that we have f of r that has x, y, z component, and x component is equal to z, y component is equal to x, and z component is equal to y. Now this is the curve that is shown in the figure. Now if I just parameterize this curve, so if you look at this is a circle and then there's a height between a and b, so this is 3 times of t, and either due to a circular motion we have cos theta and sin t. So this is a parameterized path from a to b that is shown in the figure. Now in terms of unit vector, we can write in this one. So if you remember, the formula that we discuss is that just apply the formula. For applying the formula, we need to take the derivative of r of t. So when we do that, it becomes minus sin t, then plus cos t plus 3k. So look here, now x of t equal to cos of t, y equal to sin of t, and z equal to 3 of t from parameterized value. Now when we take the dot product of dot with r of t, so just I have to replace where we have value of z is equal to 3t, so it becomes, because there is a z in the original function, so I put here 3t times I plus cos t times j and plus sin dot product. When I took the dot product, so it becomes 3t times minus sin of t plus cos square of t plus 3 sin of t. Now because this is defined from t from 0 to 2 pi, just take the simple integration and you get the result. So this is basically a line integral that use a lot. So the basic idea behind line integral is that you have to calculate the integration but through a curve. Thank you. I will stop here.